Something strange is happening above our heads. In a single week this September, Earth has faced a barrage of cosmic close calls, more than ever recorded before. Asteroid 2025 FA22, a rock big enough to flatten the city, just slipped past us at barely twice the distance to the Moon. And 3 days earlier, another object, 2025 RJ2, came even closer, skimming just under 300,000 kilometers from Earth. Dozens of smaller space rocks have been spotted rushing by, one after another, like a firing range aimed straight at our planet. Astronomers are calling it a statistical anomaly, the kind of clustering you should only see once in decades, but this year it's happening in real time. And at the same moment, 3IATLAS, a chemically bizarre interstellar visitor, is racing toward Mars on a path unlike anything in the Minor Planet Center's archives. So what's going on here? Is this just coincidence, or the first hint of a bigger pattern that could change how we defend our planet?
Asteroid 2025 FA22 wasn't discovered decades ago like some famous space rocks. It was first flagged only months earlier, its faint motion across the sky spotted by automated survey telescopes. Once the orbit was calculated, astronomers realized this was no tiny boulder. FA22 is estimated to be between 120 and 260 meters across, roughly the height of a downtown skyscraper, and it would be traveling over 18 kilometers per second during its pass. On September 18th, it made its closest approach, just 2.2 times the distance to the Moon, about 835,000 kilometers away. That's a safe miss by astronomical standards, but for planetary defense teams, it's uncomfortably close. When something that big shows up with only months of warning, it's a reminder of how fragile our early warning system can be. And FA22 wasn't even the closest one. Just 3 days earlier, Asteroid 2025 RJ2 came even nearer, slipping past Earth at only 0.78 lunar distances, less than 300,000 kilometers away. RJ2 is smaller, but still big enough to cause real damage if it hit the wrong spot. These were just the headline events. Throughout the same week, radar systems and telescopes logged dozens of other near-Earth objects rushing by, many within the Moon's orbit. For astronomers, it was like a cosmic traffic jam, and no one is entirely sure why so many showed up at once. But this was only the beginning of the puzzle.
Near-Earth objects pass by all the time, sometimes dozens per month. But what happened in September 2025 broke every record astronomers track. In just 7 days, more than 24 objects were logged inside the Moon's orbit, triple the previous weekly high. At first glance, that might sound terrifying, as if we'd suddenly drifted into some cosmic shooting gallery. But some experts cautioned against jumping to conclusions. This might not be the sky changing, it might be us. Survey power has exploded in just the last 2 years. The Vera Cruz-Rubin Observatory, still in its early operations phase, is sweeping vast areas of sky every few nights with unprecedented sensitivity. Combined with Pan-STARRS, Atlas, and Catalina, the global network of telescopes is now catching faint, fast-moving objects that would have been missed just a few years ago. The result? What looks like a sudden surge might just be the universe we were blind to all along. We're finally seeing what's always been there and realizing how many close calls we've been missing. But even with better coverage, something about September stood out. The timing, the clustering, the number of larger objects like FA22 and RJ2, it doesn't quite fit the normal random scatter of asteroid encounters. A few researchers have speculated that a hidden breakup event in the asteroid belt might be responsible, sending fragments spiraling into Earth-crossing paths over time. And that leads to a chilling question. What if one of those fragments isn't just a near miss?
It's easy to hear 2 lunar distances and shrug it off, but the danger is real. If FA22 had been aimed just a little differently, the outcome would have been catastrophic. At over 120 meters across, this is no harmless fireball. It would have slammed into our atmosphere at nearly 65,000 kilometers per hour, compressing the air ahead of it until the rock literally exploded. We've seen a preview before. In 2013, a 20-meter asteroid detonated over Chelyabinsk, Russia, with the force of half a megaton of TNT. The shockwave shattered windows in 6 cities and sent more than 1,500 people to hospitals, and that object was tiny compared to FA22. This one would carry more than 20 times the energy. The airburst would unleash several megatons of power, flattening buildings across dozens of square kilometers. The blast wave would knock people off their feet, ignite fires, and hurl glass and debris into the air. And that's the best-case scenario. If FA22 were made of iron instead of rock, it might not break apart at all. It could punch straight through the atmosphere and hit the ground at nearly full speed. That would leave a crater hundreds of meters wide and throw a mushroom-like plume of debris into the sky. And if it had landed in the ocean, which is statistically the most likely outcome, the water impact would generate a massive steam plume and tsunamis radiating outward. Coastal regions within a few hundred kilometers could face walls of water tens of meters high, giving almost no time to evacuate. One asteroid this size could change the history of a region in a single morning. But the real lesson isn't about just one rock. It's about how many more we haven't seen yet.
Humanity is better prepared for asteroid threats today than at any point in history. Dozens of ground-based surveys now scan the skies every clear night. Automated algorithms flag faint streaks moving against the stars, sending alerts to tracking stations within hours. Radar facilities like Goldstone and Green Bank can map an asteroid's shape and spin from millions of kilometers away. And in space, we're finally beginning to watch the sky from the one angle we've always missed, the sun's direction. NASA's upcoming NEO Surveyor mission will place an infrared telescope beyond Earth's orbit, where it can spot dark objects rushing in from the glare of the sun, the very scenario that made the Chelyabinsk asteroid invisible until the last second. But even with all these advances, the system isn't perfect. Objects smaller than 50 meters can still sneak by undetected until they're almost on top of us. And some of the most dangerous approaches come from high inclinations, weird orbital angles that make detection windows short. That's why September's surge has scientists so alert. Was it just a statistical spike? Or are we seeing the first hints of a new pattern, perhaps a slow-moving debris stream left by a past collision? Could a much larger fragment be hidden in the same group, waiting its turn to cross Earth's orbit? For now, the answer is buried in the data. Each close pass is logged, analyzed, and fed into a planetary defense system that is only as strong as its latest detection. And while astronomers watch the asteroid numbers climb, a very different kind of visitor is stealing their attention: an interstellar comet behaving in ways no one has ever seen.
While FA22 and RJ2 dominated Earth's immediate attention, an entirely different story was unfolding farther out in the solar system. 3IATLAS isn't just another comet, it's an interstellar traveler, hurtling toward Mars on a path unlike anything in the Minor Planet Center's records. From the very first spectra, scientists noticed something extraordinary. Its chemical fingerprint doesn't match typical solar system comets. Carbon dioxide pours from the nucleus at nearly 20 times the rate of water, a reversal of the usual cometary rules. Ground and space-based telescopes scrambled to track it. High-resolution spectra detected unusual elements, including a strong nickel signal without the iron that normally accompanies it. Theories are flying. Some suggest unique formation conditions, others propose cosmic weathering over billions of years. Every observation raises more questions than answers. The comet is slow spinning, possibly tumbling, and its nucleus shows signs of fragmentation under solar heating. Outbursts of gas and dust have already doubled its brightness in under 2 days, creating tails splitting into multiple streams. If the comet fragments near perihelion, it could produce a dazzling display visible from Earth, a spectacle, but also a reminder that not all celestial threats arrive on predictable paths. For astronomers and planetary defense teams, 3IATLAS is both a marvel and a warning. It's proof that even as we improve our detection of near-Earth rocks, the cosmos continues to surprise. While FA22 and RJ2 are lessons in proximity and risk, this interstellar visitor challenges every assumption about what's out there, how it behaves, and how we might prepare for the unexpected. And the clock is ticking. With perihelion set for late October, every night brings a new set of data, a new flash across the telescope screens, and a growing understanding that our neighborhood in space is far more dynamic than most people imagine.
September 2025 has shown us two sides of the cosmic coin. On one hand, FA22, RJ2, and dozens of smaller near-Earth objects proved how close we can come to disaster in the blink of an eye. Each one is a reminder that the line between a harmless flyby and a catastrophic event can be thinner than most people realize. Our cities, our oceans, even our daily lives could be affected by a single miscalculation or a fragment no one sees until it's almost too late. On the other hand, 3IATLAS offers a different kind of lesson. A chemical outlier, a slow-spinning interstellar messenger, it challenges every assumption about what we know in our own solar system. Its unpredictable outbursts and unusual composition remind us that even with the most advanced detection systems, the universe retains mysteries we are only beginning to comprehend. Taken together, these events are more than astronomical curiosities. They're a wake-up call, a lesson in vigilance, preparedness, and the limits of our knowledge. Humanity has made incredible strides in tracking, modeling, and simulating potential impacts, yet the sky continues to test us, to surprise us, to demand attention. The story of FA22, RJ2, and 3IATLAS isn't finished. Each close pass, each observation, each unexpected flare writes the next chapter in our understanding of cosmic hazards. And as we look up, we're forced to confront a sobering truth. The universe is vast, unpredictable, and beautiful, and our safety depends not just on luck, but on our ability to see, understand, and respond before it's too late.